Textron Aviation looked at the turboprop market, we found the single engine segment of that market quite appealing. It was a segment of the market we weren't currently serving, and when we looked more deeply, we saw that there hadn't been significant innovation in many years. Customers told us they wanted a versatile, all-new, efficient product in this category, and that was the genesis for the Cessna Denali. GE has produced over 100,000 jet engines, including the largest commercial engine in the world. They bring that innovation and proven reliability to the Denali.
The partnership between GE and Textron Aviation has been a big deal for us. The engine's power and efficiency really set the groundwork for the overall aircraft design. Having this engine to work with allowed our engineers additional flexibility to focus on cabin comfort while maintaining range, speed, and payload objectives. We have optimized the airframe-propeller interaction, propeller design, and engine operating parameters. This collaboration generates a product that is quieter, more efficient, and with greater performance.
I represent over 6,000 engineers in GE Aviation, together with 3,000 scientists at our GE Global Research Center. We're hard at work developing new applications, bringing new technologies and new capabilities to the aviation space. We have over 38,000 engines out flying each and every day. At any given time, 300,000 people aloft being powered by our engines. Every 2 seconds, a GE engine somewhere in the world lifts an airframe off the ground. We will continue this 99-year legacy, leveraging the learning from our installed fleet and bringing new technologies each and every day to create value for our customers.
The ATP is really unique in this marketplace because it combines technologies from GE's larger commercial transport engines that are used on Boeing and Airbus aircraft and brings those technologies into the business jet aviation market segment. Some of the unique aspects of the ATP in the Denali is a single lever control. The propeller pitch, propeller speed, and throttle are all in one lever. The engine starts with a FADEC, it's a full authority digital engine control, just like we have on our large commercial transport engines, providing improved performance, less workload in the cockpit, longer time between overhauls. It really changes the piloting experience. We know the DNA of your engine, we know how you flew it, and we can monitor it to make sure that it is performing properly. And if there's any service that's required, we can be there before the service is required to ensure that you have a great flight experience and that your aircraft is ready to go whenever you want it. It will provide a customer experience like no other turboprop in history.
GE Additive is a new business, new technology. When we designed the Advanced Turboprop, we took 855 parts and we reduced them to 12. So automatically you're eliminating a lot of probability of mistakes and handoffs when you reduce the number of components. We started using additive in 2010. So additive really makes the product better. It makes the product lighter. It combines several parts to one. It reduces the cost of the product. It helps with eliminating the weak links because you take many parts that previously you would weld or you fasten together, all of that goes away. That's why the product becomes better, more durable, and more reliable.
What the Denali really brings to this market is a more luxurious and larger cabin. And to push that cabin through the air at the right speed and at the right range requires a more powerful, more fuel-efficient engine. And the ATP can deliver on all of these. So the engine is designed to have 4,000 hours with no intermediate overhaul, which is about 30% more than the benchmarking fleet today. What's really exciting about the Denali is it's a chance for two companies that are really the best at what they do to work together on a new product. Textron Aviation is clearly the world leader in the general aviation space, and GE is the world leader in the aircraft engine space. And so this is a chance for us to work together and bring the best of what we do to a new product in Denali, which I know will really change the expectations of customers in this market.
The Denali is hands down the best-in-class single-engine turboprop aircraft, and GE is the perfect fit. We're confident and excited to get the aircraft in the hands of our customers.
Great. Welcome everybody. I know I had some pause when I got on the airplane to fly here because of the tragedy last week. I understand this is the first large convention that's taken place since the tragedy last week, and we certainly have our thoughts and condolences with the community and the people that are affected by last week's events. Las Vegas is a shining city filled with great people, and we feel for everybody. So I'm Brad Mottier, and I lead the business of general aviation and integrated systems businesses. For those that are unfamiliar with BGAIS, BGA are all the engines that are not military or commercial transport that GE manufactures. And integrated systems are all the products that we manufacture, design and manufacture, that are not engines or avionics. So we just saw a great video. I get goosebumps every time I see that. Not when I'm on the screen. I notice that person doesn't have quite as much gray hair as I have today. I don't know if that was doctored by our communications people or not, but the last 5 or 6 months, I think I must have aged like 10 years or something. But it was in 2005 that we formally announced the Advanced Turboprop with Cessna here. There we are drinking some champagne, and last year I brought a bunch of additive parts, and we have Guy Norris there looking through one of those parts, and there's Guy in the second row, so thank you, Guy. We are using your picture. And then this year, if you think about this, it's two years from when we launched the program. We are running the first conforming complete engine. That is an unbelievably fast program. It's the fastest that we've ever done at GE, and I would say it's probably the fastest that other engine manufacturers. It's 18 to 24 months faster. We have a fantastic international team. Paul Corkery's here in the front row. Paul leads this program for us. We'll talk a little bit more about that. So today we're on the brink of running the first engine. And that'll happen hopefully with the holidays and everything. Always have my fingers crossed when I say we're going to do something at the end of the year. But we are scheduled right now to fire that engine, the ATP, for the first time at the end of December. That engine has 900 sensors on it. I asked, why do we need 900? Wouldn't 800 be enough? It would certainly cost less, but everybody tells me we need that. So this is a picture of how we're preparing for the big run. Those are some stators. They're there. Our first engine will take place in Prague. We've reconfigured some of our test cells that were originally designed for the H80. They can now take the higher horsepower of the Advanced Turboprop. And we're preparing that right now. All initial design work is complete, obviously. And we have about 85% of the parts are already there. They're being assembled. The rest of them are coming. All of the additive parts we talked about, taking 855 down to 12, all those are done. So as you can see, we have test cell monitoring rooms set up. We're just in the process of assembling things and getting going. This last week, we had a major run. I guess it was a week and a half ago. We ran our axial centrifugal compressor vehicle tests at our Global Research Center, one of GE's global research centers that Gary Mercer, who's the head of our engineering, talked about the 3,000 people located around the world that are working on GE engines. Some of those are in Munich, and we ran this. This particular rig had 500 sensors on just the actual compressor. This allows us to fully understand the compressor, validate all the performance, and that sort of stuff. And the technology we're using it's the same stuff we use in our big commercial engines when we test the new designs. But in the ATP, has a lot of new features that haven't been seen before in this marketplace that we've talked about before, like variable stator vanes, cooled turbine blades. Some of the structure of the engine is also cooled, in addition to the single lever propeller FADEC control, where we can control all three propeller pitch, propeller speed, propeller torque, the low pressure turbine speed, the gas generator speed, the fuel flow, the variable stator vanes, and 3 different bleed valves. We have more control, degrees of freedom on this engine than we have on just about anything else we've done. This is a big test for us. And here's a picture.
So it's an exciting day for ATP. We're here at the Engineering Technology Center in Munich, Germany to fire up our axial centrifugal compressor vehicle. This vehicle is to help us de-risk our aerodynamics, air mechanics, operability, and it will also give us a glimpse into how the compressor operates to make sure we're getting the pressure ratios we designed.
Roughly a year after we have finished the design work of the ATP compressor, we have now today started testing this compressor. Great accomplishment, everything ran completely fine and perfectly smooth.
We did it together with an international team made of engineers of Holland, Czech, Italy, and Germany. So made it running successfully, and I'm really proud of the team.
I appreciate also the support we got from the other sides to get that thing running today, and yeah, we are very happy that we fulfilled the requirement today, and we are looking forward to the next days to get that compressor really smoothly running.
You guys saw on my first slide we were toasting with some champagne. Here we are toasting, so when we have big achievements, we tend to do that. Whoops. So here's the Advanced Turboprop. You've seen this slide before. 2,000 thermodynamic horsepower. This is an all-new design. A lot of people keep asking me, is this just an outgrowth of the H-series engines that we currently manufacture in our facility in Prague? The answer is no. This is a clean sheet design. It's a 16-to-1 pressure ratio, 20% less fuel burn, 10% more power than what's available today powering airplanes. So first engine run is going to be at the end of this year. Next thing I'd like to talk about is our passport. So our passport engines continue to accumulate hours. We've reached more than, well, 3,360. We're on our way to 4,000 hours and 4,000 cycles to date. We have more than 4,000 hours, and we'll have more than 4,000 hours and 8,000 cycles by entry into service, which will be hopefully sometime next year. Passport received FAA certification in 2016. We're now in the process of industrializing our factories. We're manufacturing the production hardware. We're starting to assemble the production engines. So this thing is real. It's not just a paper engine. It's up and flying. We've transitioned from the development phase program, the CERT program. We're supporting Mottier on their flight test program. I think flight test vehicle number 4 is here. If you get a chance, you can go check it out. It is one impressive machine. In addition to the engines, the aircraft is equally impressive. And so we're moving into the entry into service phase. Here's a picture of the airplane out there. I've had an opportunity, I haven't been on this one, I'm going out to check out the interior on this one, but I've been all over the airplane up at the facility in Canada. It made its first flight was at the end of September. It's here today, so I'm headed out there to take a look at that on Wednesday. 4 flight test vehicles, Mottier, as I mentioned. They're at the test center in Wichita, collectively accumulating nearly 900 flight hours so far. Great program, everything's moving forward. Then we have our H-series. This is the small size turboprop. This is the engine that we acquired from Walter Aircraft Engines about not quite 10 years ago and infused some GE technology into the engine to upgrade it. The H85 you'll see on this chart is now certified. So we have a 75 H75, an 80, and an 85. The numbers stand for shaft horsepower. The other thing about the H85 is it has a new gearbox, which slows the propeller down. So the max RPM on the propeller is now 1950 on the H85. On the H80, it's 2080. We also have the single lever power control is certified. So this is the first, this is an engine and propeller control. So the pilot literally has just one lever. Very similar to the ATP as far as one lever. However, with the Advanced Turboprop, because we have a full authority digital engine computer, we can control a lot more things. But this provides a very similar experience, very simplified cockpit. And the flight testing on this was just recently completed on the next in King Air. The H85-200 has its first home, which is, as we said, has been certified. This is the LET 410NG. So we have been powering the LET 410, which is an aircraft manufactured in the Czech Republic. It's used for commuter operations and humanitarian relief. It's very rugged, flies into dirt strips and things all over the world. What's unique about this is not only the engines are upgraded, the avionics are also upgraded, and this is a new wing. So this is a very, very capable aircraft, and we're in the process of producing the first engines for this and production aircraft. Now I normally let GE Honda do their press conference, but they're not having one this NBAA. So they asked if I would kind of share where we are on the HF120, which I'm happy to do since we're a 50% partner with our great partner Honda. The HF120, we've delivered, there are 100 plus engines we've delivered. This again is about 2,100 pounds of thrust. It's on Honda Jet today. We have 14,000 cycles in service and about 16,000 flight hours at this point, and it's running great. And the combination of the engine and the airplane are really super. GE has a Honda Jet. We are getting our second Honda Jet, expanding our regional fleet based at our factories, our headquarters in Cincinnati. So we took delivery of our first Honda Jet in April. I think we started flying, our first flights were April 21st. We have 300 plus hours on already. And the limitation for us has really been the number of pilots. So we are training and qualifying more pilots. The airplane flies about 5 days a week. Our most productive trip, we had 11 cycles in one trip. We use this aircraft for flying between our plants, the GE Aviation plants and suppliers and customers on the East Coast. Prior to this, we would, if we wanted a corporate aircraft, we would have to get one dispatched from the Northeast. That's where the GE corporate aircraft used to be located, up on the Northeast. Bring them in, then we would take our trips. What we find is that we put 3 or 4 people on board. It's an hour and 15-minute flight. We have 22 facilities within striking distance of the Honda Jet. It is an incredible productivity machine for us. So we've flown 100,000 miles, 600 plus passengers. We get our second Honda Jet, which again will be based in Cincinnati in January. That'll be serial number 93, I think, or close to 100. The CF-34 turns 34. So this is a 34th year of the CF-34. They're in service with more than 900 business jet operators around the world in more than 69 countries. This engine is a workhorse on the Bombardier Challenger. The CF34-A1 and 3B1 have accumulated more than 62 million flight hours and 55 million cycles since entry into service. And I'm happy to say that we were, again, for the second year in a row, this is the #1 reliable engine, turbofan engine, in the AIN annual survey. So this is really, it's really phenomenal. If you add up all of the engines, all the CF34 family, because these are also used on regional aircraft, 7,000 engines, 4.4 million passenger flights, 113 million takeoffs and landings. It's pretty phenomenal, 140 million flight hours. So we use this as most of its operations on commercial flights, airline flights. But as you saw in the video, we take all that learning and that experience and put it into our business general aviation engines. Another thing that we have spent quite a bit of effort on, I think this is the first public discussion of it. I mentioned it a little bit at eBase last year, but if you think about hybrid electric, where you have hybrid that's producing some electric power and you have electric motors, storage, control, distribution, that's what we do in the integrated system side of our business, the electrical side. So in the F-35 Lightning by Lockheed Martin, for example, we provide all of the primary, secondary distribution control batteries, the very high-tech lithium-ion batteries that can have a very rapid discharge at temperature extremes, unique chemistry. We provide the storage and the battery control and the battery charging. So you have that on one side, and then you have the hybrid part, which is generator. We provide the generators on F-18s, on a wide variety of other military platforms and black programs and things, and UAVs, Global Hawks, and things like that. So you marry that together and take an engine and electric and the expertise in electric generation, control, distribution, and load and storage, and you can put it together. So we started a couple years ago. I guess it'll be 3 years ago at this point. We kept this quiet for 2 years. We were given the challenge of producing 1 million watts. David Joyce, my boss, vice chairman, said, hey, I want the engine team and the integrated system team to come together and figure out how to pull 1 million watts of power off of an existing engine. And so we went on a quest. We did this. We ran it in a test cell at GE. They're in Evendale. The Air Force, the military are pretty excited about this. Now you probably don't need 1 million watts of power on your business jet, so you guys can kind of think about what you might use 1 million watts for. But there is a need for 1 million watts of power. We've since taken this engine and electric power configuration and have put it into an altitude chamber at NASA Glenn and took it up and have run this through the complete flight envelope of an F-110 engine. That's the engine that's on like an F-16, for example. So this is really a crowning achievement. No one has ever produced that much power. We pull power off of both the high pressure and low pressure spools of the engine. So that means off the gas generator and also the low pressure turbine. And all of that has to be synced, the loads, the controls, with maintaining the operability of the engine. This is no small feat. So we're pretty proud of that. And I was at a conference or someplace and I let this slip, so then some people asked me a question about it. And so I said, okay, well, I better come clean and kind of share this a little broader. And so that's why we're doing this. I got in a lot of trouble for actually mentioning this about 6 months ago. But now everybody's happy that I did. We also announced, I think it was at eBase, that we had signed an agreement with Ariane to work with them on an engine, to define an engine for supersonic transport. And I can tell you that that is moving forward. Their goal is obviously to design and certify the first supersonic business jet. And our teams are working together. We just completed a kind of what I would characterize as a blitz period with them to define the potential architectures for these engines. We have been working with Ariane for about probably more than 2 years, but kind of in just an exploratory phase. We're now joined with them to actually come up with the actual engine hardware design, well, the hardware configuration, the architecture of the engine. And the first survey's in, and I'm pleased to say that we're thrilled to be #1 again in the 2017 AIN Product Support Survey. I think this is a testament to the expertise and passion we have on our team and the incredible service professionals that we have. We have expanded since 2008 when we formed the BGA division. We've gone from 10 authorized service centers. We now have 50 around the world, and as I mentioned before, we have those CF-34s operating in 69 countries, so it's important to be around the world. We have 250 field service engineers. We built this network not only for the existing CF-34, but also for the Advanced Turboprop and the Passport, which of course is a long-range aircraft. So very happy about that. We continue to take our on-point agreements, expand the on-point service offerings. This is on-point is that's our Power by the Hour program. A concierge, kind of a tip to tail on the engine program. We now have prognostic health management. I mentioned earlier, well, in the video, we talked, I think it was Gordy, the chief engineer, talked about the DNA knowing, or maybe I did, somebody did on the video, about how we will know how you fly your engine on the Advanced Turboprop, so we know what prescriptive maintenance to provide. Actually, that's something that we started to do on our commercial engines about 18 months ago. I think was the first 18 months, 2 years, something like that, where in the past, if you had a service issue, you might issue a service bulletin with a serial number range, kind of broad. And then everybody would go out, there would be an expense, a disruption, inconvenience for people to carry out that service bulletin. What we're doing now on our commercial engines, our newest commercial engines, and the Passport and the Advanced Turboprop both have all the sensors, the pedigree, and the systems in place to capture the DNA of the parts that go into the engine. Then the engine is assembled, it is tested, we record all of the important parameters of how that engine operates and how those parts interact, how we model how they interact. You then fly the engine, you fly your airplane. We know, based on where you're flying, what the weather was that day, what your D rate was. Did you fly through any volcanic ash? Were you in the Middle East flying through a dust storm, etc. All of that. And then we model, we actually fly the engine in the computer, we call it our digital twin. We actually fly a digital twin of every flight of every serial number engine. We then take that information, and if there is a need, say we learned there's something wrong with a part or an assembly or something like that, we monitor each engine individually and we can go and do prescriptive maintenance. So the FAA, after we've proven to the FAA that we can do this, we are now doing prescriptive engine serial number maintenance and getting away from broad service bulletins. So lots of times people do a service bulletin, they go do an inspection, they don't find anything, right? I mean, that happens if you're an airplane owner, that happens. Sometimes you do find something, right? Well, we want to eliminate all the stuff where you don't need to do the inspection. And so we're bringing that into our prognostic health stuff on our Passport and the Advanced Turboprop, just like we have on the large commercial engines. I think that's going to be a game changer for maintenance. It's a huge game changer for us. Our customers, the airlines save tens of millions of dollars a year because of the digital twin systems, processes that we put in place. So we're taking it to the next level. We're also installing QARs, quick access recorders. So as part of our on-point agreement, we install a quick access recorder on your aircraft. And every time you land, it looks for a 3G or a Wi-Fi signal and burps off the data for that particular flight. We then goes into our database. We can take a look at it. We can run the digital twin type of algorithms. So a lot of people have asked me about our commitment to this industry and what we're doing here. We think we're on just the start. I think that the Advanced Turboprop is going to be a catalyst for new cockpit designs, new aircraft designs, new flight procedures, new maintenance, etc. We're really just at the start. This is what we've spent since we formed Business General Aviation Division in 2008. So this is in the last, eight and a half years. We've invested a little over $1.5 billion in new engine developments. Those include the investments we've done on the H series, the Passport, the GE Honda, Advanced Turboprop. That's a pretty good size number. We'll have 4,700 engines in service across all of those platforms. Of course, the Passport is not in service yet. That's going to happen within the next 12 months or so. And we're on turboprops, light jets. On the mid-size, we have focused on electric power distribution. And of course, on the large cabin is electric power distribution and the engine, the Passport. So we have a little display here. I have nothing to show. Last time I was here, we had all kinds of things that we were showing people. But we have stuff to see out of the booth. So there's our booth, C11820. And we have an ATP engine mock-up out there. We have a full-size Passport engine out there. We've got an H series, we've got some additive parts, and we have a number of people from the factory, the engineering design team, the program offices here at the show. So if there's any questions about what I've talked about here or other things, we'd be glad to see you at the booth.